Welcome to Miles and Dash's PAL 15. Wow, it's been rolling for 2 minutes already. Welcome to Miles and Dash's PAL 15. Woo. Today's PAL is Scott the Painter. Scott the Painter is going to paint the floors of 16 rooms. He is in room number 1. He can go through any door. See diagram, which Dash is going to draw right now. Bigger than that.
I can't reach.
He cannot. Just make it lower. Just make it lower. Yeah. He cannot return to any room once he has painted it. Slow drying paint. Question number 1. In what order should he paint the rooms? Obviously, number 16 must be last. Dashel, I will draw the diagram because you cannot draw a diagram. So tired.
Yeah, but you need to tell me which one.
Well, if it's 4x4, then you can start in room 2, 4, 5, 7, 10, 12, 13, or 15.
So the question is how can
And
you tell me which one to start?
action.
Question number 1 for Dashel. In which order should he go through the rooms?
You just add it up. That's what you're trying to figure out.
We figured out that Scott should go through either 13 or room 4 without painting them, because we were a little messed up by this at first, because we went on an assumption
Should he always start in the
that
first room?
you had to start painting in
Should he
room
always
1,
start in the second room?
but you just have to start like in room 1, and so you should start in room 13 or 4, then
So-
go side to side and
He would have to,
paint in the room.
he walks to room 4,
You should start.
then he paints room 4, 3, 2, 1, 5, 6, 7, 8, 12, 11, 10, 9, 13, 14, 15, 16, then he leaves, and he gets paid.
Or another one
So
could be
then
13,
what he
9,
should do if it's
5, 1, 2,
2 by
3, 9, 10, 14.
Okay, you're reading them.
3 by 2.
I can't read.
Okay, he could also go from 1,
So draw.
walking to 13, going 13, 9, 5, 1, 2, 6, 10, 14, 15, 11, 7, 3, 4, 8, 12, and 16, walk out the door and get paid.
What's that?
Question number 2. After you determine one path for Scott the Painter, figure out what other paths he could use to paint the floors. Write down all the paths you can think of.
Oh,
This is the part where we go in fast motion, writing all of them down and list it out.
I'll read on.
We're gonna just do it like,
And then we should be like for each one. So like.
so. There are actually 3, 6, 9, 12, 4, 12, 12, 15, 18, 21, 24. There are 24 possible ways that we found that he could go through. Here they are.
That means 24 times 16.
What?
You're gonna have to write a whole lot of them.
Whatever.
We can't do it in that time. Okay.
You can start from this and go to this. Going 2, 1, 5, 6, 7, 3, 4, 8, 12, 11, 10, 9, 13. So that is just one of the many you could do.
3 by 2.
Here's the list
So
of
there's still 6
numbers
rooms.
in order. Like,
Wait, no, we should just like put
So
it
if
up
there's
on
6
the
rooms,
I'm saying if it's 2 by 3, where should he start?
We
Question number 3. What patterns do you see with these solutions? Why do the patterns work? Well, the pattern that we realized.
Yes, we did. Together as teams.
Be quiet. We noticed many patterns. Firstly, the last two numbers in the sequence were always to be 15, 16, or 12, 16. And that the 13th number was always 14, 11, or 8. We also found that each place to start at had only 3 sequences, or 3 ways of working. And finally, if the floors laid out in the building were like a chessboard or a checkerboard, 1 being white, 2 being black, and so on, only the black squares would be able to have Scott start there. So like, we have this, 1 is white, this is black, 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 this is black. So you would only be able to start at the shaded black ones, which would be 2, 4, 5, 7, 10, 12, 13, and 15. And have 3 unique sequences. I'll give it to you once I read the question.
Okay.
Question number 4. What if there aren't 16 rooms, but 9, or 25, or some other perfect square? Describe / explain the pattern that would work for Scott to paint the rooms.
Whoa, cow. Okay.
Oh, that sounds good. I'm going to eat this during history class.
We figured out that if there were 9 rooms, the chessboard thing would be basically the same exact thing. 1 being white, 2 being black, so on. Except the white.
Hold on.
Ziga.
Is also one.
You're not saying anything.
Except the white squares would be the only
I
ones
don't know how
that Scott could start on. And the rule is for
Well, otherwise you're
the
just
rule is
staring at
that
your
for
computer and I don't know if I'm saying wrong, right, or
Really, just read it.
the rule is
doing
that
what?
for odd amount of squares it is white. For even if it is
But I'm not figuring it out.
like this.
Joker.
There's not enough.
What's your computer got?
It's also in writing.
You should keep it that. That makes sense.
Huh? What did you get last week?
If there were to be 9 rooms, the chessboard series. If there were to be 9
I'll
rooms,
just ask
the
questions.
checkerboard theory would still pretty much be the same.
What is it?
1 being white, 2 being black, except the white squares would be the only ones Scott could start on. The rule is, for an odd amount of squares, like 9 being odd, 9 squares is odd. It is white, like only the white one can work. And if the number of squares is even, like 16, only the black ones would work. Number 5.
I'll do it.
You wouldn't understand.
Am I just like not even
What are you trying to figure out?
Wait.
trying to find one more?
Question 5. What if the configuration of the rooms is not a square, but a rectangle? Describe / explain the pattern that would work for Scott to paint the rooms. So, for rectangles, it would really depend on the width and the height, but we're guessing that the chessboard theory would somehow apply once the...
Like this, just extend it. You would just extend it out, and it would work the same way.
And then that would work after some of the patterns would be established.
So the same thing being like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If there are 15 squares here, so it'd be odd, so the rule would still work.
Yes.